All right, guys, so today we're going to talk about modeling. So setting up equations for word problems and using them to solve different scenarios. And instead of just working on exponential models, I want to talk about the difference between linear and exponential. So we're going to do both today. So this one might be a little bit long. So linear models should be review. When something has linear growth, it means that the same amount is being either added or subtracted to your initial amount over a certain period of time. And we know that because you're adding and subtracting, we know the linear model is y equals mx plus b, right? That's the equation of a line, so that's the linear model. And then here's an example. You start with 50 bucks, that's going to be your B, right? You earn an additional 100 every day, that's your rate of change, so your M. And then if you plug those numbers into the model, it's y equals 100x plus 50. Okay, so we've done that before. Now, exponential, on the other hand, is when the same amount is being multiplied or divided. Over a certain period of time. And it's a different form, obviously. Exponential models are of the form y equals a times b to the, let's put x power. Sometimes they put t because it's usually time, but we'll just put x. Okay, let's look at this one. You start with $1. A is the starting amount. Okay, so $1, that's going to be A. And let's write that down here. A is the start value. Now, B is how much you're multiplying or dividing by every time. So if you're doubling, doesn't that mean times 2? So that's going to be B. All right, and then just like this one, y and x are always just y and x. So the model would be y equals a, which is 1, times b, which is 2, to the x power. And that's it. Okay, so let's go through and set up, let's just do one of each so this video doesn't get too long. All right, first one, you got to tell me what type of model is it, linear or exponential? So a library has 8,000 books. It is losing 3 books a year. Now the key is to look for a word, a key word. Does losing mean, if you're losing 3 books a year, is that addition, subtraction, or multiplication or division? And hopefully you would say, well, if you're losing 3 a year, that's subtraction. And when it's added or subtracted, it's going to be linear. Okay, so you would say explain why. You would say losing means subtracting. Okay, so you're going to have to explain why. No guessing. Okay, so write an equation. If it's linear, it's y equals mx plus b. And in this story, let's see what's what. The y-intercept b is the 8,000. And if you're losing 3 books a year, that's like the slope or the rate. So that's the m. Also, if you're losing, the slope is going to be -3. So that's important too. All right, put that together. Y equals mx plus b. It's y equals -3x plus 8,000. And now the last part is we're actually going to use this model to solve a problem now. Okay, so now it's saying, hey, if 10 years pass, how many books will be left if it follows this model? Okay, so where are we going to plug in the 10? 10, X stands for years and Y stands for number of books. So the 10 is going to go into the X. We probably should have defined our variables first. So yeah, if you plug in 10 here, y is going to be negative 3 times 10 plus 8,000. And then you guys could solve that. So y is going to be, let's see, what's 8,000 minus 30? That's 7,970, what are we on? Books. Okay, so that is a linear one. All right, turn the page and let's see what the next one is. Okay, let's do 2. Why not? Okay, a bank account starts with $10. Every month, the amount of money in the account is tripled. Okay, tripled. Is it linear or exponential? So triple means you're multiplying by 3. Multiplying is exponential. Okay, and you would say why? You would say because tripled means multiplied. And that means exponential. Okay, our model. So our model is y equals starting value times rate change to the x power. Okay, so what is our starting value? 10. So A is 10. B is, if it's getting tripled, then B is going to be a 3 and then to the x power. So that's our model. And now it's saying, how much money will there be after 6 months? Okay, so in this one, months is the x, and you just need to plug it in and solve for y. Okay, so if we plug that in, I'll show you how to do that. It's 10 parenthesis 3 parenthesis caret 6. And it's going to be a big number. $7,290. $7,290. All right, not bad, huh? Okay, now there's one more type, exponential growth and decay with percents. And this one unfortunately has another formula. All right, so let's do one of these guys. If it's growing exponentially by a percent, this is the formula for exponential growth. Okay, C is the initial amount. R is the rate written as a decimal. So you got to convert the percent to a decimal. And T is the time. And then if it's decreasing, sorry, we have a typo here. This should be decreasing. If it decreases by the same percent every year, this is our model. It's the same thing, but instead of a plus, it's a minus. Same thing though. C is the initial amount, R is the rate, T is the time. All right, let's just try one of these. So again, this is only if it's growing or decaying by a percent. This is when you have to use this formula. Okay, so number 1, is it linear or exponential? Now, whenever it's increasing or decreasing by a percent, that's automatically a clue that it's exponential. Why did you choose that? Percent increase is always exponential. Okay, what's our model? Our model is y equals, what's the starting value? The initial amount, I think it's 6. Okay, a newborn is 6 grams. Okay, and then we have 1 plus R. Now, R is the percent, but you have to convert it to a decimal. And to convert a percent to a decimal, you move the decimal over 2 spots to the left, so it becomes 0.10. And then we're raising it to the t power, and the time that's passed is 6 weeks. Oh, actually, we're just going to set up the model, so we're going to leave it as t now. So this is the model. And t is the time. Okay, now part C, we're going to plug in. If 10 days have passed, we want to know the weight, so we plug 10 in for t. All right, so if we do that, it's 6 parenthesis, 1 plus 0.10 parenthesis, caret 10, because 10 days have passed. And you guys should get, let's round to the nearest hundredth, 15.56, so we'll say about 15.56. I think this is in grams. Okay, so today we learned how to model with linear and exponential, and also with percent ones. And then we're going to practice this all tomorrow, so if it's a little confusing, we still got time. All right, thanks for watching, guys.